Let's look at some more properties of functions. Let's determine whether a function is an even or odd function. A function is even if f of the opposite of x equals f of x. In other words, the graph of this function is symmetric with respect to the y-axis, where the y-axis is an axis of symmetry for the graph. A function is odd if f of the opposite of x equals the opposite of f of x. In other words, its graph is symmetric with respect to the origin. Let's look at an example. So let's look at h of x equals x over x squared minus 1. Let's calculate h of the opposite of x. So let's substitute in the opposite of x for x, simplify. This equals the opposite of x over x squared minus 1. So h of x equals x over x squared minus 1. H of the opposite of x equals the opposite of x over x squared minus 1. They are opposites of each other, so h of the opposite of x equals the opposite of h of x. So h of x is an odd function, and its graph is symmetric with respect to the origin. Okay, let's determine where a function is increasing, decreasing, or constant. A function is increasing if, on an open interval, if for any x1 and x2 in the interval where x1 is less than x2, f of x1 is less than f of x2. A function is decreasing on an open interval if for any x1 and x2 in the interval, with x1 being less than x2, f of x1 is greater than f of x2. And a function is constant on an open interval if for any x in the interval, the f of x values are equal. Okay, that sounds a bit confusing, but let's look at a graph. So here we have a graph with a whole lot of different things going on, but it does have distinct endpoints. It doesn't have to have endpoints, this example just does. So let's identify different important features of the graph. So this point looks to be negative 7, 5, negative 4, negative 3, negative 3, 0, 0, 0, 1, negative 1, 5, 7, 8, negative 2, and the final endpoint is at 12, 1. So let's see where this function looks like it's increasing. So you basically want to see where the graph looks like it's increasing when we look at it from left to right. So here, this first part, and we'll describe the open interval using the x values of the boundary points. So from negative 4 to negative 3 is an increasing interval. Another one is right here. So from x's 1 to 5. And then finally, here at the end, where the x goes from 8 to 12. So on these three open intervals, the function is increasing. Let's look where the function is decreasing. And as it sounds, we're looking for where the function looks like it's decreasing from left to right. So on this first interval here, where x is going from negative 7 to negative 4, then over here where x goes from 0 to 1, and finally here where x goes from 5 to 8. Okay, let's see if the function is constant anywhere. Well, if a function is constant, its f of x values are equal, or we see a horizontal line segment. We have one of those right here, from x equals negative 3 up to x equals 0. So here are the intervals where the function is increasing, decreasing, and constant. Okay, finally, let's look at some local minima and maxima. We've looked at some absolute ones in the past, but there is such a thing as local minima and maxima. A local maxima, a function has a local maximum at a value c if there is an open interval containing c so that f of x is less than or equal to f of c for all x in the interval. F of c is considered a local maximum value. Local minima. A function f of x has a local minimum at c if there is an open interval containing c so that f of x is greater than or equal to f of c for all x in the interval, and f of c is a local minimum value. Okay, so let's look at our same graph, because this sounds complicated, but local maximum, local minima, we might be able to figure this out by just looking at the graph. Okay, so local maxima. These are going to be the high points. So they're going to be like the maximum points, but they may not be the absolute maximum points. They might just be the maximum points on an open interval. So this endpoint, an endpoint cannot be a local maxima or minima, so no. Okay, we can't have one here because it's constant to the right, so we won't have an open interval. Same thing here, except it's constant to the left, so we won't have an open interval where it's the maximum. Okay, but right here, 5, 7, this point is a local maximum point. So we have a local maximum at x equals 5, and f of 5 is equal to 7. Okay, again, an endpoint, nope, we don't have a local maximum there because we can't have an open interval with if we have a point at the endpoint. Okay, let's look at local minima. So let's look for minimum values. Okay, right here at -4, -3, this is a local minimum point. Okay, we have one here at 1, -1. And finally here at 8, -2. So we have 3 local minima, but only 1 local maximum.